has to be on the team, then I really don't get to pick all 5 members, do I?
Only 4.
I really only get to pick 4 members. It says, oh no, I'm sorry, wait a minute. It's competition teams of 6. Yeah. So that I'm picking 6 people, but if Patrick has to be on the team, I'm really only picking 5. Now, how many people were in the group altogether? No, how many people were in the pool?
12.
There were 12. Patrick is one of these, right? So he's out. So I have to pick 5 people from a pool of 11 people. Because you have to take Patrick out. There is 1 Patrick and 11 others. Would you agree with me in my pool? I am taking Patrick. So if you want to do 1C1, you can. There's 1 Patrick and you're taking him. And you are taking 5 of the remaining 11.
Sorry.
This is just like a deck of cards. You have queens and you have not queens. You got Patrick and you got not Patrick. Right. Anybody else have a question about one of the homework cards? John? 10. One tin contains 10 and 12. 10 cookies, 12 brownies. The other tin contains 60 brownies, 2 cookies. That is selects one treat. What's the probability that it is a brownie? Okay. Okay, so let's think about this. Let's try this for a minute. First thing, okay, Gabby's going to pick a treat. The first thing she has to figure out is which tin she's going to take it out of, right? So there is a 50-50 chance that she'll take it out of tin 1, and there's a 50-50 chance that she'll take it out of tin 2. Would you agree with that? Now, if she chooses tin 1, she's going to get a brownie or a cookie, and likewise, if she chooses tin 2, she's going to get a brownie or a cookie. In tin 1, what's the probability she'll get a brownie? 12 over 22, and a cookie is 10 over 22. Because there's 22 items in the tin, 10 of them are cookies and 12 of them are brownies. What about any other one? 16 18ths and 2 18ths. Now there's 2 ways she can get a brownie. She can get a brownie this way out of tin 1, or she can get a brownie this way out of tin 2. Would you agree with that? So what's the probability of picking a brownie from tin 1? 12/44? Just multiply those. Pick tin 1 and a brownie. And what's the probability tin 2 and a brownie? That would be 1636. I'm feeling very lazy today. I'm going to let my calculator do this for me. So 12 divided by 44 plus 16 divided by 36 equals, math frac, 71.99 if we're into fractions, or 0.718 if we're into decimals. Does that make sense to you, Tom?
You multiply those numbers, right?
You multiply these.
You
Add.
Oh, add.
I hope I added those. That's what I was supposed to do. Why do I add those? What's the key word? Yeah, I added them. What's the key word? Pick tin 1 and a brownie, or tin 2 and a brownie. All right, anybody else have something on here you had a question about? Katie.
Okay. For all of 3, why is the denominator just 2? Like it's 9 factorial, like over.
Okay, wait a second. You are going to make a necklace with all these beads.
Yeah.
And every one of those has a denominator of 2. Okay, it's not a probability question for sure, right? So it doesn't have anything to do with that. Can somebody explain that? We actually talked about it the other day.
Reflectiveness.
Reflections, yeah.
I got
Remember, if it's a necklace, a bracelet, or a keychain. In other words, if it's a circle that I can hold out here and you look at it from one side and I look at it from the other side, then we have to take out half of the arrangements because they're really not different. We're just looking at them from different sides.
Okay, so when it doesn't have a clasp, it's 9 though. I'll get that either.
What is the class?
Okay,
Yeah,
remember
what is
the
the
clasp,
clasp?
remember what a clasp does. Does your necklace have a clasp that you're wearing? Yeah, okay, would you take it off? Or, no, not that one. Would you take it off with the clasp? Watch her, she's getting ready to do it, right? Stop right there, hold that up so everybody can see it. What is that? That is not a circle. What is it? It's a line. When you put a clasp on a necklace, it doesn't act like a circle anymore. It acts like a line. So if there are 9 beads in a circle, would be 8 factorial.
Okay.
But if it's 9 beads with a clasp, it's 9 factorial because it's a line. Put a clasp on it and it's really a line.
Oh, okay.
When you take it off, watch like she did, it's a line.
Okay.
All right, who else had a question about one of the homework problems? Maggie?
2A.
2A. You are to choose 5 cards. I think we talked about this yesterday. We want 5-card hand, so the probability, the denominator is going to be 52C5. Anytime you're doing a 5-card hand from a standard deck, it's a probability, the denominator is going to be 52C5. Now, I want at least 1 king. Now, think about this for a second. At least 1 king. What does that mean, at least 1 king? It means it's a 5-card hand, so you could have 1 king, or you could have, this is going to be very long. You could have 1, or 2, or 3, or 4, right? So we could have 1 king, or 2 kings, or 3 kings, or 4 kings. Now, each of these is going to be a separate problem. And then what will we do with each of these separate problems? Add them up. Okay? So this would look like, okay, how many kings are in the deck? 4, and we're picking 1 of them. But we also need 4 more cards, because it's a 5-card hand, and they are kings. So how many not king cards are there? 48, and we're picking 4 of them. So this is 1 king and 4 other cards. Or, okay, now what would 2 kings look like? 4C2 and 48C3, or 4C3, 48C2, or all the kings, 4C4, and your 1 extra card. And all that is over 52C5. Now, if that makes sense to you, then you can do the problem that way. I'm not going to do the problem that way because I have to type all that into my calculator and that just takes me too long. I'm going to do the problem backdoor. I'm going to do the problem by taking 100% minus the probability of no kings. Because if I deal you a 5-card hand, could you get 4 kings in it? Yep, probably won't, but you could. Could you get 3 kings? 2 kings? 1 king? What is the only other thing that could happen? If I deal you 5 cards, you could get 4 kings, 3 kings, 2 kings, 1 king, or none. That's the only other thing that could happen. You could get a hand with no kings. So I'm going to take 100% or 1 and subtract 48C5 over 52C5. Because what's this? There are 48 cards in the deck that aren't kings, and I want 5 of those. That will guarantee me no kings. So if I take 100% minus the probability of no kings, what does that leave me with? The probability of some kings. Not necessarily all kings, but any kings. This is no kings. So I could get 1 or 2 or 3 hands with kings would be left. Tom?
On number 3C.
Okay, wait a second. So are we good on that? Now, you do not have to do the problem this way. It's a lot shorter, but this will also give you the correct answer. Absolutely, that will give you the correct answer. So if that makes sense to you, then do it that way. Just know you got a lot of typing ahead of you. Remember that the probability of what you want equals 1 minus the probability of what you don't want. Does that make sense? You can either find the probability of what you want, that's this, or you can take 1 minus what you don't want. That will work also. Okay, Tom, which one?
3C.
Okay, so I've got all these beads. So I've got 2 gold, 3 blue, 5 green. All the beads of the same color are identical, so I gotta think about how I'm gonna deal with that. The blue has to be kept together. And there's a clasp. All right, here we go. The blue, start with, the blue has to be kept together, okay? So how many things am I really arranging? 2, 3, 8. There's 5 of these and 2 of these, that's 7, and there's a bundle of those, that's 8. So I'm really arranging 8 things. Okay, wait a minute. But it's in a circle, but it has a clasp. So do I stick with 8 factorial or do I drop it down to 7 factorial? Stick with 8. There's a clasp. I treat it like a line, so I'm going to start with 8 factorial. But I got to multiply by 3 factorial. Why am I multiplying by 3 factorial? Because those 3 blue beads, when they get bundled, they can be bundled or arranged 3 factorial ways. But the beads of each color are identical. How do I handle that? Divide by 2 factorial, 3 factorial, 5 factorial. And it's a necklace, so what else do I have to divide by? 2 for the reflections. Got it all? There's a lot in that problem. What would change if we took a clasp off, if it's a no clasp? What would change in the problem? 1 thing. The only thing that would change is that would be a 7. All right. Who else had a question? Maggie?
I have a question. For number 8, the answer, for my answer, I thought I put 4 factorial. Would that be okay instead of putting 4 factorial? Because they do the same thing, but they're just
Oh, it doesn't matter, because I want the answer anyway. Okay. So I want 24.
Okay.
Yeah. No, that doesn't matter. You think of it either way. Yeah, Emma? 2F. Okay, let's look at this one. This is a tough problem, Emma. Part of it is easy, but there is a pretty significant complication in there. So we need 3 of one suit, 2 of another. So I gave you an example there so you would understand. 3 clubs, 2 diamonds. We can have 3 hearts, 2 clubs. I mean, do you see, that's what we're talking about, that kind of situation. Okay, so let's start with just a specific example. Let's pretend the problem just said, what's the probability, these are probabilities, right? No, just as how many different hands, so it's not probability. How many ways could I get 3 clubs and 2 diamonds? Let's just start with that. Okay, what would that look like? 3 clubs. And? Perfect. So this is the specific case for 3 clubs and 2 diamonds. Would everybody agree with that? Now, what if we were doing 3 hearts and 2 spades? What would that specific case look like? Same thing. So all of the specific cases would have this number. Would you agree with that? So what do we really need to figure out? How many cases there are? So could we just make a list like this? Sure, you can always do that. It's not too huge. I wouldn't want to do it in some problems, but you could just make a list, all the possibilities, and count them up. You could also stop and think about it from this standpoint. How many, when I come up with a case, I have to pick 2 suits, right? Like clubs and diamonds, or hearts and spades. I have to pick 2 of them. How many suits are there? 4. So would this be for C2 or for P2? Now be careful. I could have 3 clubs and 2 diamonds. Could I also have 3 diamonds and 2 clubs? So the order I pick them does matter, doesn't it? So this would be the number of ways that we could pick the 2 suits. And then this is the number of ways I can get 3 of one and 2 of the other. So this is the actual answer to the problem. That's tricky. That's tricky. That might be a bonus question. That's tricky. This part's easy. I would be totally comfortable asking you, how many ways can I get, 3 diamonds and 2 clubs? That I'm perfectly fine asking that question. But this part is a little bit tricky. Tom?
When's the test?
Tuesday. But we're starting the next section. We have to do some work. So we're going to work Thursday and Friday. We'll start the next stuff. Monday we'll kind of recap a little bit, and then Tuesday's our test. Okay? We're trying to give all the play people a break, and I'm assuming then that we'll all go to the play, the musical.
I'm going.
All right. Who else had a question about the homework? Any other questions? Yeah, Katie?
We do 4B.
4B.
4 and 4C.
I have to wake somebody up once every 3 days. So in other words, the probability of having to wake somebody up is 1/3. I have to do it 1 out of 3 days, so the probability I'm going to have to wake somebody up is 1/3. What is the probability that I will wake someone up exactly 3 times in the next 6 days? So there are 6 days, and I'm going to pick 3 of them. Does the order I pick the days matter? Do I care which 3 days it is? No. So I'm going to start with 6C3. There are 6 days. I'm going to choose 3 of them to wake somebody up. On any of the 6 days, I'm either going to wake somebody up or I'm not going to wake somebody up. I want to wake them up 3 times, which means I'm not going to wake them up 3 times because I'm doing it for 6 days. What's the probability of waking them up? 1/3. What's the probability of not waking them up? 2/3. There will be the answer to the question, Katie. Now, when it says at least 3 times, this would be part of the answer, because this is 3 times. But then you would also have to do 4 times, 5 times, 6 times, and then what would you do with all those separate answers? Add them up.
So it'd be 64.
Yep,
And then 4 and 4.
yep, no, 4 and 2, there's only 6 days. So if you wake them up 4 times, you're not waking them up 2 times. Anything else from that? All right, then if you would look at, in the packet, there's a sheet called Chapter 9 Extra Practice. Find it, it says Chapter 9 Extra Practice 9.1 to 9.3. This sheet actually continues over onto the next page too, and all of the answers are there, but try not to look at those right now. Nope. I don't know what your homework's going to be. I gotta revamp this since I've changed it up a little bit. Number 1, a class consists of 10 students, 5 boys, 5 girls, and 1 teacher. How many ways can the students sit in a row of chairs? 10 factorial. We should not even have to think about that. 10 factorial. Sit in a circle. 9 factorial. Sit in a row. If all the boys are together and all the girls are together. 2 factorial. 5 factorial. 5 factorial. Now, I need somebody to explain that on the off chance there's still someone in the room who doesn't get that. Who can explain this for problem number 2? Who will explain that real quick? Olivia, can you explain this?
Because there are, let's see, two groups.
2 groups,
So
exactly.
and then
Here's your boys, here's your girls, 2 groups, good, 2
and then
factorial.
5 girls. And 5
The
is
group of 5
boys.
girls can be arranged this many ways, and the group of 5 boys that many ways. Yes, very, very good, perfect. Sit in a row, if boys cannot sit next to other boys, and girls cannot sit next to other girls. Okay, so basically, what does that mean? We're alternating, right? We're alternating. So how many ways can we do that? Okay, let's say we're gonna put a boy here. Okay, we can put a boy here. All right, so if I put a boy there, how many choices do I have?
Just another girl.
How many boys are there? I have 5 choices, right? Then if I put a boy there, who's gotta be here?
Girl,
A girl, and I have 5 of those. Now I'm back to a boy. So there'd be 4. And then I'm back to a girl, there'd be 4. So you can see how this is going, right? So the boys can be arranged how many ways? 5 factorial, right? If you separate it. And then the girls can also be 5 factorial. Now what's wrong with that? Why is that not done?
Because you can start with a girl.
I could start with a girl.
So
And what would this look like if I started with a girl? What would this look like if I started with a girl? Same thing. So I have this many ways for boys starting first. I have exactly the same number for girls starting first, so can I just double this? Now, another way to do that, it equals the same thing, but it might make more sense to you is, if you were going to sit kids alternately, how many choices do you really have for this first blank? 10. So you could put a 10 there. Now, I don't know if that's a boy or a girl, it's one or the other, right? But whichever it is, this one can't be that. So how many options would you have for this one?
5.
No, you'd have 5. 5. Because whoever you put here, you have to put the opposite gender here, right? So you don't get to pick from 9, you only get to pick from 5. And then, how many choices do you have here? 4. Because whoever you put in this first spot, there are 4 of that gender left, and then it goes down. So this, believe it or not, that's gonna equal the same thing, because if you pull one of these 5s out and times it by the 2, that's how you get the 10. Okay? You can think of it either way. How many ways can we stand in a row for a picture if the teacher must be on one end or the other? Okay, now wait a second. How many ways did you say we could seat them in a row or stand them up in a row? 10 factorial, right? So the kids can be arranged, here are the kids, and they can be arranged 10 factorial ways, right? Now, let's say the teacher's on this end. There's 10 factorial ways to arrange these people if the teacher's on this end. How many ways are there if the teacher is on the other end? 10 factorial. So what's the answer to the question? 2 times 10 factorial. You have 10 factorial ways to arrange the kids. That's who you're arranging. You're not arranging the teacher. You're arranging the kids, 10 factorial ways, and then you're going to put the teacher on the left or put the teacher on the right. So there's 2 10 factorial.
Plus 2 or?
No, times 2. Yeah, because it's a 10 factorial plus a 10 factorial. There's 10 factorial ways with the teacher on the left, or there's 10 factorial ways with the teacher on the right. So you can either say 10 factorial plus 10 factorial, or you can say 2 times 10 factorial. Does that make sense? How many ways can we elect a president and a vice president from the students in the class? 10 P2. How many ways can we elect a king and a queen from the students in the class? The king must be a boy and the queen must be a girl. 5P1 times 5P1. All right, I'm going to look over to the next page. Look at number 3. On the next page, look at problem number 3. There are 10 people at a party. Each person shakes hands with everybody else. How many handshakes will occur? What did you say? 10 factorial divided by 2. Can you explain your logic to me?
Because since there's 10 people, that makes it 10 factorial, but then divided by 2 since it's 2 people per 1 handshake.
So me shaking hands with you and you shaking hands with me is the same handshake?
Mm-hmm.
I like that logic a lot. I'm still confused by 10 factorial. There's 10 people. So you got 10, 9, 8, 7, 6. Okay, what does that 10 represent? Okay, but be careful because the first person does not shake hands 10 times, does it? Okay, let's think about this for a second. We have 10 people in the room. Every handshake involves 2 of them, right? So we're pairing these people. So if I want you 2 to shake hands, I'm gonna say I have these 10 people, I'm picking you 2 to shake hands. So I have 10 people and I'm choosing them 2 at a time. Basically to shake hands, aren't I? 10 people, 2 at a time. Does the order I pick them matter? Go back to what John said. Does it matter whether he shakes hands with me or I shake hands with him? No. The answer to the question is very simply just 10C2. It's 10C2. Number 5, in an urn, there are 6 red, 8 white, 4 blue. I am going to pick 4. What's the problem? No. In how many ways can we get all 4 the same color? So that means, now this is gonna be the last one I'm gonna do, guys. I know you're getting tired, hang with me. We've not done a picking marbles out of an urn problem before, so let's see if we can figure this out. We wanna pick 4 all the same color, so that means 4 red, or 4 white, or 4 blue. Would you agree with that? How many ways can I get 4 reds out of this? I'm gonna reach in and grab out of this urn. How many ways can I get 4 reds? Think of it like a card problem. How many ways can you get 4 diamonds? 13C4 would be diamonds, right? And where did the 13 come from? That's how many diamonds are in the deck. I want 4 red marbles. How many red marbles are in the urn? 6. 6C4. That's how many ways I can get 4 reds. Now, if you were doing probability, if I said what's the probability of getting 4 reds, then you would divide this by 18C4. This would be the probability of getting 4 reds. That isn't what it says. But that's where the 18 would come in. What's 4 whites? 8C4? How come? Because there's 8 whites to pick from. What would this look like? 4C4. Do you understand why I'm adding those numbers up? Now, one more time. If I said, what's the probability of this happening, you would take this and divide it by the total, which is 18 taken 4 at a time. That would be the probability. That is not the answer to this question, but it could be a probability question. Okay? All right, now I need to give you an assignment. John, would you turn that off? And here